on this computer. Okay. All right. So you want to do question, which one? Oh, 9?
Yeah, 9, 10, those ones.
Okay. Let me zoom this up a little bit. Okay, so 9 half log 2x plus 3 log 2y plus 8 log 2z. Okay. So we've got addition here, right? Okay, so let's see what you got here. Where's my pencil? Okay, so let's see what you got. You got, okay, so you put the half there. You put the 3 there, and you put the 8 there. Okay. Then what did you do? Then you wrote it as one log, right? X half y. So this should be a subscript 2, right? It's not a big 2, right? That one? That's a subscript 2, right? Y3 Z8. Yeah, that looks okay. All right, did you do this in class with your teacher?
So yeah.
Okay. All right, that 9 looks okay. 10, actually, what did it say? Say simplify? What did it say? Simplify. Express as a single log, if possible, simplify. Okay, 9 you can't really simplify any further. 10, let's see what you did on 10. 10, what did you do on 10? You took the half that's on the outside and okay, so we got a subtraction sign there and a plus sign there. So this one will be division. This one will be multiplication. Okay, so you left the half on the front. ZX6, yeah, that's right. This one and this one you wrote on the top, and then you divided by this one. Yeah, that seems right. Y3. Yeah, yeah, that's good. Now ask
I'm
yourself,
only
can you simplify this line any further?
um I don't think so. I think he just left it there.
If you multiply that half in, nah.
Could we actually just go through these two like from scratch?
9 and 10, yeah. Okay.
Hmm.
Um, okay, so for this line right here, all they did was take this half and put it right here above the x. Take this 3 and raise it to right there. Take this
Hmm.
8 and raise it right there, which is this second line, which is the second line.
So
Uh,
log 2x to the half
this first one will
plus,
be log 2x raised to the half, yep,
and then
which is this one,
second one plus log 2y to the third
plus log 2y
plus
cubed, yep, yep,
log 2z to the eighth.
plus log 2z8. Yep,
So the one log answer would be log, hold on, my pen's not working.
yep.
Log
2
2,
root x. You can say root x or x to the half, same thing. Y3 z8.
okay, I don't have to put the plus there.
Which is this line. Okay, well, see this plus right here and this plus right here. The notes that you sent me, not these notes, but the notes you sent me, was that yesterday?
I
It
think so,
has
yeah.
it has the log properties. So instead of when we're dealing with logs and we have an addition sign in the middle like that, it's really multiplication.
Mm-hmm.
So this line right here, there's your multiplication. This times this times this.
Mm-hmm.
So that's why you write it in one log. Actually, let me pull up that other sheet you sent me. I'm gonna show you what I'm talking about. Jordan, March 27th. It's this one right here. Properties of log. Yeah, this one right here. Let me share this. Oop. Let me share this one right here. So that question that we just did is let me see here. This rule right here. This one right here. Where's the multiplication? me scroll down. I thought I saw it in here the other day. Yeah, this one right here. See this one right here?
Mhm.
Let me circle it for you. See this right here? That's the one we just used. See the two of them multiplied by each other? Log A
Yes.
u times v is just broken out the u and the v with an
Hmm.
addition sign in the middle.
Uh-huh.
So that's one of the properties. Let me go back to the other one. That's where we used number 9. This is where we applied that property right there. We got addition sign right there. We got an addition sign right there. We got an addition sign right there. All that means in logs is multiplication. This one times this one times this one. So that's that, what's it called? Quotient rule. Let me go back to see what it was called again. It's called product property. Product property. Let me download this one. Okay, yeah, product property. Number 1. Can you see the screen right here? 4.3. Property
Yes.
logs. Product property. So that's the one we just used a minute ago. All right, number 10, I believe is the same concept. Okay, so number 10, we've got a minus sign right there and an addition sign right there. This one's going to be division. This one's going to be multiplication. All right, so let's go through it.
So when it's subtraction, it's division, and when it's adding, it's multiplication.
Exactly. So what you just said is number 1 and number 2. So look, number 1, there's your addition. There's your multiplication. Product property. Quotient property number 2, there's your minus sign. There's your division sign.
Hmm.
So, well, and then actually we also used this one a minute ago too. If you have the n in the front here, it's the same thing as moving the n up, oops, to the exponent where they use, like moving it right there. That's this one right here.
And for 10, when you're making it one log, if the number is, well, if you're subtracting, then it's gonna be on the bottom of the fraction.
Let's go back. You're talking about number 10,
10.
was it? You're talking about this one right here, right?
Yes.
All right, so let's rewrite that so we can look at it in a different way. This is the same thing as half. Let's do the addition. Let's put these two together because they're both addition, right?
Hmm.
Rewrite this. Half log 4x plus 6 log 4z. I'm just going to rewrite it in different order, and then I'm going to put the subtract one on the end. 3 log 4y. All I did was rearrange the order. All I did was first one still first. I just switched. I put the second one in the third position and the third one in the second position. Okay. I didn't really,
Hmm.
all I did was switch it around. Are you with me?
Hmm.
Okay. I didn't. Okay. So now these first two are multiplication, right?
Hmm.
Then, so these first two, which is multiplication, is these two. And then the division one is this division one.
It would just be x to the, hmm.
Well, they're leaving the half on the front. Don't ignore the half. Just leave it on the front for the time being. So half.
Mhm.
Let's write this one as one log and leave this one on the end. So that's half log 4 and then x times. Okay, so now we're using that what was the third one? The third one was called what log or what rule? Power property. Okay, so let's rewrite it. Let's use the power property. Log 4x plus log 4 z6. So I'm moving the 6 where now it was in the front. Now I'm moving it up here. Okay. I'm just applying my was it quotient property? No, power property, my bad. Power property. Okay, so now let's keep going. Are you with me?
Yes.
All I did was move this 6 right here and make it the exponent right there, which is this one right here. Okay, so now let's keep going. And then the next one, I'm going to do the same thing on the last one. So minus log 4 and y3. I'm just moving that exponent up, right? This 3 that was in the front now goes up there, right?
Mm-hmm.
Okay, so now, oops, let me rewrite that. Okay, so are you with me on this line?
Yes.
Okay, now we're going to simplify further. Okay, so now let's write the first two. Well, you can just write it as 1 from here. Half, leave the half on the front. These two are multiplication, so log 4 right there. X times z6 on the top. And then this minus 1 is division over y3. There you go. Which is this line. Same thing as this line. All we did was write this intermediary step.
Mm-hmm.
Okay. That's it. Just apply your rules. Apply your product rule, your quotient rule, and your power rule. This one, okay, let's break down number 9 quickly. Let's rewrite the first one. Log 2x to the half. Did we do this one already? Log 2x to the half, right? We move this half to right there. We're going to move this 3 right there, plus log 2y3 plus, and now we're going to move this 8 to right there, plus log 2z8. Okay, so plus sign, so we know it's multiplication. Okay, so now just write it as 1. Write it as 1, which is log 2 multiply all 3. X to the half. Oh, I forgot the 2. Log 2x to the half. Y3z8. Okay, this is your final answer on that one. And this is your final answer on that one. Okay. Just break it down and use your properties. Any questions on that? You good on that one? Those two. You good on those two? Yeah. All right. All right. All right. Let's see what else you got. 9. So you miss any one of these? Okay, those first 9 or first 10 you're good.
Yeah, we're just plugging it into calculators.
Say it again.
We're just plugging into calculators for the first couple ones.
Oh, okay. Okay. Yep. All right. 9 and 10, 11, 12, you're good. Now, see,
Yes.
this one, you're just going the other way. Now they give you one. Now they say break it out into several. It's just going the
Yeah,
other way
these
if I
were
want to
kind
go.
of confusing too.
Okay,
Did
so
you go over some?
let's go over these ones. Okay, so all right, use the properties of logs to expand each. Okay, so we have one term there, 2 terms there, and a third term there. Okay. So all right, let me read it. We know these two are multiplication, so those two are addition. And we know this one is division, that's on the bottom. We know that's subtraction.
Mm-hmm.
Okay. So let's break it out. Log x4 plus log root y, right? There's your multiplication, right? There's your plus sign. This is this one times this one, which is that right there, right? Now we're going to do the other one. Now let's do the other one.
From
And
here, we just is it just subtract what's on the
on the bottom,
denominator?
log, yeah, exactly. Log, Okay, so three. I forgot to write the three in the front. Write the three in the front. So log minus 3 log z6. Okay, so we use the properties of logs to expand each. These two are multiplication because of the addition, and then this is your subtraction, so that's division.
I have
Uh,
to solve them.
yeah, now you can go like one step further. Put the 4 in the front here, put the half in the front here, and I believe you can put the 6 in the front here. Let's see. Okay, so the 4 that's in the exponent on this line, you're going to say, bring it down. So 4 log x. You know that root y is what exponent right here? What's the exponent right here?
Half.
Half. There you go. So bring down your half here plus half log y minus this one here. Let me think about this one. This one here, I'm thinking leave the 6 up there. 3 log z6. Use the properties of log to expand each. Yeah, this one should be good. 6. That one should be good right there. There's your final. So you took 1 log and you broke it into 3. Okay.
Mhm.
12, same idea. Same idea on 12. Now you have 3 things that you're multiplying, right? So it's going to be 3 addition signs. This times this times this. How can we rewrite rewrite this one? How can we rewrite this as z to the what? What's the exponent right here? What is it?
Half.
Uh, well, if this 3 wasn't there, it would be half.
Okay, so it's z. I mean 3.
It'll be z to the half like that. There's your root z, right? And,
Uh-huh.
let me think about this. I'm thinking, is it 3 over 2? Let me see. Let me think about that one. This one would be this is the z half, right? Z half raised to what exponent would go right here? 1
3.
1 over 3. 1 over 3. So then this is z to the 1 over 6.
How do you know why to do that? Like,
Okay, good question. This is how I know. Okay, so we know a couple of things, right? Z to the root z is z to the half, right? We know that. What's the number right here?
um,
If there's no number, what number is it?
10,
2.
2.
Okay, so
Why is that?
anytime you see a root sign like that
Okay.
and there's no number right there, it's 2. So what's the second root of x? That's what that means, right? So if
Mhm.
now what's the all right, let me back up a second. Let me back up a second. Okay, so if there's no number right there, it's assumed to be 2. Okay, so now what about this? Z to the 3, 3. What is this? Z to the what? What's the exponent? If this is 2 and this one is 1 over 2, what is this one? Z to the
1 over 3.
1 over 3. There you go. Okay, so now let's go back. Oops. Erase that one, erase that one. Okay, so now let's go back up here. Okay, so let's see here. We know root z is z to the half, right? So there's your z to the half, right? That's this part right here, right?
Hmm.
So now that's that part raised to the third root, 1 over 3 root. So that's just 1 over 6. Let me think if I'm doing that right. No, my bad. I'm thinking too much. I'm thinking too much. My bad. It's 1 over 3. It's just 1 over 3.
Okay.
I'm doing too much. I'm doing too much. So cubed root of z is the same thing as z to the 1/3. Just like z there is, we know that's a 2 right there, imaginary 2. So this is z to the half. All right, so since we know the z to the 3, let's break it out into 3 logs. So this one would be what? Log 3 what?
Um, log 3 to the
X to the 6, right?
uh-huh.
Plus the second one is log y to the 9, log 3 y to the 9,
Mm-hmm.
plus the last one is log 3 z. What's the exponent here?
1/3.
1/3. There you go. Z 1/3. Okay, can you simplify this, or this?
Yes.
Okay, so what is this first one equal to?
3.
That one's equal to 3. What's this one equal to? The second one.
Oh no. No. I think the first one's 2.
So we say that 3 raised to the x would equal x to the 6. No,
No.
that doesn't make sense. No, we can't simplify this one. The second one, can we simplify? 3 to
Yes.
the
9
x
is a square.
equals y to the 9. Okay, so how can we simplify that second one?
3. 3 times 3 is 9.
Okay, so we can rewrite this. 3 times 3 is 9.
Does it have to go for all the numbers?
What do you mean?
The when I'm simplifying, do all the numbers need to be simplified as well, or just one that can be simplified?
Say that again.
When I simplify at the end, do all the numbers need to be simplified by the same number?
What do you mean simplified by the same number?
So like let's say I was simplifying by 3. I would I would it would have to be 3 because all the numbers there can be simplified by 3. Like 6, 9, 1/3.
So okay, so what would this one equal? What would this one equal? What would this one equal?
But I think I'm wrong because it has to be square,
Yeah,
right?
yeah, remember your basic log rules. Log 3x6 would equal, say, y. So then you would say 3 to the y equals this one. I don't think you can simplify any of those any further.
Mm-hmm.
Okay, actually, what did he write here? He wrote 6 log 3.
Um,
Let's see
say
here.
that again?
Your teacher wrote 6 log 3 there in the on the
Oh
second.
no, this is my writing. Me
Oh,
trying
that's
to
good.
solve them.
Oh, okay, I got you. Yeah, I think you're good at that level, at that stage right there.
Mm-hmm.
This looks okay. Let me look at this. This one you've got log 3 x6. Okay, this one looks okay. This one, yeah, this one looks okay. For this one, it's just z, not z to the half, but z to the 1/3.
Mm-hmm.
Got, I think that's, what is this right here? Z to the half. Yeah, it doesn't look like you can go any further than that. Oh, I guess you could. Yeah, I guess you can bring down the exponents. Yeah, you could bring down the exponents. 6 log 3x plus 9 log 3y plus 1/3. Yeah, okay. This line is your last line. Log 3z. There's your final. Just bring down the exponents into the front. Your what is it called? The product rule? No, power rule. Power rule. Okay. Good on those two?
Yes.
All right. All right. That was 11 and 12. Okay, so what you want to do 13 or 14 or both?
Mhm. Both.
All right, let's take a look.
Can I try to solve it?
Yeah, go ahead.
Okay. So when I stretch the equation, I think it's going to be 7 log um 7 log um square. Is it do I no, I can't do that. Okay, never mind. I got it.
Just do these two,
Squared
add
x.
these two. Yeah, break down those two first. Those are you're adding those two.
Okay. Squared x. Well, x squared.
Yeah, x squared, yeah.
Um,
Well, not x squared, but remember that root x is x to the half.
okay.
X to the half, x to the half.
Y to y squared.
Yeah. Okay, so what you want me to write? Log 7. What was this one?
Log no, I put 7 log. Is that correct?
No, it's not 7 log 7.
Okay.
Log 7 x to the half. That's the first one. Now what's next?
Um, hmm,
Your
oh, to
multiple.
the half. Hold on, I'm doing it wrong.
Your multiple. It could be root x here. Same thing.
Okay. Um, minus
Okay, don't
no,
do
the
minus.
y.
Yeah, yeah. These two are multiplied by each other. So what sign goes right here?
Add
There you go. Log 7. What's this part now?
minus w.
Well, this will be y2 here, right?
Yeah, y2 before the subtract
Yeah,
w.
exactly. Now subtract minus log 7. What?
W4.
W4 minus log 7. What? Z5.
Hmm.
Okay, good. Now can we simplify that? Now just bring your exponents down to the front.
Hold on, let
Half
me rewrite this.
log, 2 log, 4 log, 5 log. Oh, this is log 7, not log 4. Log 7.
Simplified.
Yeah, just bring the exponents to the front.
Okay.
Half log 7x. What's the next one?
2 log 7y
Yep. Minus 4
minus
log
4 log 7w
4. No, there's just
minus
W.
minus 5
Yep.
log
There you go.
7z.
There you go. Yep. There's your final answer.
Okay.
14. How are we going to do 14?
Do I still start with parentheses? Hold
Uh,
on,
you
can
you could, yeah, you could, but you can't simplify that any further, right?
yeah.
Okay, so then what's next?
Um, I find the singular numbers, so it would be log. Oh, my pen.
What do you mean the singular numbers?
Find get them by themselves. So it would be like
Break it out. You mean break this out?
Yes.
Okay, before we break it out, what should we do before that? That
Um,
that's kind of like step two. What's step one?
Making the 5 a 1/5.
Yeah, we could do that. That's before that's true. That's true. We'll do that, but what's the real step one?
I'm not sure.
Distribute.
Oh,
So what do we have? We have log or 2 log, right? We have what do we have? We have 2 log 4 y3. What's the x going to be now? What is what is x to the 1/5, like you said a minute ago, times x? What's the new exponent there? What's the exponent right here?
um,
Just add them, right?
mhm.
This is a 1 there, right? So what's 1/5 plus 1? 1/5. This is really 5/5, right? 5/5 is the same thing as 1, right?
One. Yes.
So this is what, 6/5? X to 6/5, right?
Mm-hmm.
So 2 log 4 y3 x 6/5. Do you see that? We put the 2 on the front. There, this 2 right here is this 2 right here. We put it on the front. The rest we kept the same. That we kept the same, which is that right there. Then we multiplied this one and this one, which is what we did right here. Get it?
Not really.
Okay, so let me ask you this. Let's do a simple example. Okay, you get the idea that we're distributing into the brackets, right?
Distributing the y3.
Well, we left that one alone, right? There's your y3.
Okay.
So this whole part right here, this whole part right here, we didn't touch. All we did is rewrite it right there.
Mm-hmm.
Okay, this 2 we put on the front, which is that 2 right there. Then we multiplied fifth root of x and this x. So all we did was add the exponents, which is this line right here. So that's how we get the x 6/5. Oops. So it's kind of like this. Let me give you a simple example of what we're doing. If we did something like, let me give you an easy one. What's this one? 3x x minus 2. What, distribute this for me? Go those 2 times each other, those 2 times each other. What's the answer here?
3x to the second.
How did you get 2 here? How did you know that's 2 right there?
Because 2x is just 2.
1 plus 1 is 2, right?
Yeah.
Okay, and then minus 6x, right? Same thing we're doing up here. Same thing we're doing up here. Same exact thing. We're adding the exponents. All we're doing is adding 1/5. There's your 1/5, x to the 1/5, and there's your x1, x1. All we're doing is adding the exponents, just like you add the 1 here and the 1 here. You added the 1 and 1 to get the 2. Same thing here. 1/5 plus 5/5 is 6/5, which is this. Get it?
Okay. Where do you get the one from? Are you getting the one from
Which one?
when you turned the 5? Where's the 6?
Okay, so you're asking about this right here?
Yes.
Okay. Where
I'm
am
not
I
understanding.
where am I getting the 1/5 from?
Mm-hmm.
Okay,
Oh
so
yeah, you put it's 1/5 there, but why is it a 6 now? Why is it a 6/5?
Okay, good question. Okay, you're with me that this one equals 1/5, right?
Yes.
Okay, now you're with me that this is just one, right? The exponent here is one, right?
Hmm.
Okay, so there we're multiplying those two together.
Is that for all the questions I have that it's gonna be 1?
If there's no exponent there, it's assumed to be one.
Okay.
That exponent right there is one. They didn't write an exponent, so it's just assumed to be one. So now go back to your exponent laws back in the day. When you had the same bases, just add the exponents. So x 1/5 times, we can rewrite the 1 as 5/5, right? That's also 1. Now just add your exponents. X is 6/5. Okay. That's this one right here. X to the 6/5. Are you with me?
Hmm.
Okay, so now we're gonna, okay, so we distributed the first two. We distributed that one. Now we're gonna distribute this one. So what am I gonna minus here? What's the rest of it?
Um,
Just minus the same thing, right? Minus this whole thing. Minus log 4 y3 fifth root of x
and why is it minus?
because of this minus. This
Okay.
whole thing times -1. Those two multiply by each other. It's kind of like this. 3, what's this one? What's this right here? 3x minus 3, right? 3 times -1 is -3. Same idea. You get it?
Kind of.
Okay, do you understand the 3 times -1 down here?
Yes.
Okay, so how do we get this -3 right here?
You multiply 3 times -1.
Okay, just imagine this part is 3 right here. 3 times -1. 3 times -1 is just negative this thing, -3.
Hmm.
So same idea. If this whole thing was 3, just imagine this was 3 right here. 3 times -1 is -3, which is this part. This here's your -3. -3. -3. It's this whole thing. It's this whole thing right here times -1. What's that whole thing right there times -1?
Itself. I mean,
It's yeah, exactly. Negative itself. Negative itself. Yeah, right?
hmm.
Okay, so now it's just simplify. So just brush up on your exponent. Okay, so this one, the exponent laws, just brush up on your exponent laws. Don't
Hmm.
get don't trip off of that because it looks crazy. Just simplify that. If that was a 2, this would be -2 here, right? Don't get tripped. Like don't worry about that. It just looks crazy. Yeah, it looks crazy, but just multiply that same thing by -1, which is there's your negative, there's your just and just rewrite it on the end.
Okay.
All right, so now let's simplify it. All right, can we simplify this? How are we going to simplify this? We can bring the exponent, we can bring this exponent down, we can bring this exponent down, we can bring this exponent down, we can bring this exponent down. Get it?
Yes.
2 times 3 times 6/5, what? Log 4 y x, right?
Hmm.
And then this one is minus 1/5. No, 1/1. Let me rewrite it. Minus 3 times 1/5 log 4 yx, right?
Mhm.
Now I just multiply those three, multiply those two, and that's it. What's 6 times 6 is 36. 36 over 5 log 4 yx minus 3 over 5 log 4 y over x. Okay, so now actually this is the same as this. So 36 over 5 minus 3 over 5. What is that? 36 over 5 minus 3 over 5 is 33 over 5.
Three, yeah.
33 over 5 log 4 yx. Log 4 yx. Make sense? Make sense?
Yes.
Okay, cool. All right, what about 14, 15 or 15, 16?
Um,
Want to do those?
yeah, we can do those, and I'm good.
Okay. All right, let's do those. All right. These ones are just your properties. Just apply your properties. Your three properties, your product property, your division property, and your power property.
Mhm.
All right. 15. Okay. How can we do 15?
Um,
Log.
log. Wait. Is 5x 1/5 and 7 just 7?
Say it again.
Is 5x 1/5?
5x. No, no.
Because it has a square root.
It has a square root and you have to add 7 to it. It's so you can rewrite it like this though. 5x plus 7 to the half. Like that. That's the same thing.
None of those are divisible by half, though. No, but yeah, none of them are gonna split into half.
What do you mean split into half?
You couldn't solve. You couldn't solve it. It's not gonna be like a square root. No,
Yeah,
those
yeah,
aren't.
yeah, 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 right, exactly. 5x plus 7 is not a perfect square. Yep. All right, so let's see what we can do here. Log 3, 4x, 5x plus 7 to the half. What can we do now? That's the same thing, right? So now what?
Um,
Just right. Okay, we can put the half in the front. Can we do anything else? We can put the half in the front. So a half log 3 4x. I think we can multiply these two now. 5x plus 7 and that. I think we can multiply these two. Not actually, let me think about it. Not multiply them, but break those two out. You know what I mean? Okay, so this is a multiplication here, right? Now
yes.
break it into two. So we know it's multiplication. So now break it into two. Half log 3 4x. What's the other one? What's this one right here? And what sign goes there?
Um,
Say it again. It's multiplication, so you go add right there.
is
And
it
then what
just 5 times 7? No, it's 4 times. So 20 x plus 7.
Don't multiply these two. Don't multiply that. Break it into two. Break it into two. Half log 3 4x plus half log 3 5x plus 7. Because this is multiplication here, remember your log rules. Break it into two. There's that one, and there's that one. Get it?
Yes.
One of the earlier questions we were doing, we're using that product rule. Yeah, product rule.
And why a half again? Why is it
Because
4x plus half? Oh,
4x.
never mind, never mind, never mind. I got it.
It's see this half that we this
Yeah.
half was there, then we brought it down there, then that one breaks into both of these.
Mm-hmm.
Yeah, yep. All right, 16. How are we gonna do 16?
Okay.
So 16 now. First, before you do anything, what are you gonna do first on 16?
Distribute
Yes.
3x.
Okay, so we got 12xy.
Wait, no. They're
Yep,
different variables.
that's okay. Log 2, 12xy minus 3x, right? That's the top, right?
Mm-hmm.
And the bottom is, we'll just leave the, actually, how can we rewrite the bottom? 5, what's the exponent to the z?
2.
Let's see here. Okay, so what is z squared, the third power of z squared? That's the same thing as z2 all to the 1/3, right?
Mm-hmm.
Which is what? Z to the
1 over z.
2/3. Just
Okay.
remember your exponent laws, right? 2 times 1/3 is 2/3. So 5z 2/3. Okay, now apply your um your log properties. So this one is subtraction. So we know that's actually maybe we should have simplified that first. Can we simplify that? No, we can't simplify that. Okay,
Isn't the one at the bottom subtraction?
the one at this right here,
Mm-hmm.
isn't that subtraction? Why would it be subtraction?
Because it's the denominator.
Because you're dividing. Yes. Okay. Good point. Actually, maybe we shouldn't have distributed this. This is one, and this is one, right? Let's leave it like that. Let's leave it like that. Let me back up. We're gonna we're gonna write it as we're gonna write it as one. So log two 3x plus log two 4y minus one, right?
Mm-hmm.
Okay, now what? Now, yeah, like you said a minute ago, this one would be minus, right? Minus log 2, what's this? This is 5z to the 2/3, right?
Mm-hmm.
Now can we simplify that? This one we can't simplify, this one we can't simplify, this one we can simplify. Just bring the 2/3 into the front. That's all. This one, log 2, rewrite the first two, log 2 3x plus log 2 4y minus 1. This is a g right here. And then minus 2/3 log 2 5z. There you go. The only difference between this line and this line is this 2/3 is now in the front right here. Okay. So what we did on this one was break this into two, addition. There's one, there's two, there's your addition. Then we divide, since this is division right here, there's our subtraction sign. And then we put this one right there. Then we move the 2/3 to the front. That's it.
Mm-hmm.
Okay, that one's not so bad. That one's not so bad. Okay, so that's a G right there. Log. All right. Are you good on those two? All right.
That's pretty much it. It's just the top part is simple. It's plugging in and doing the same thing, but without the distributing. But the distributing part, I just need to remember the steps on.
What do you mean the top part? The questions on the top? The first.
Uh-huh.
Okay, let's take a look. Use the change of base formula to simplify each log expression. Okay, I was looking at your notes right here from the other day, and they're saying something about big number and where is it? Big number and little number or something like that. Where was it?
Maybe at the top.
Yes. Yeah, right here. Think log big number over log base number. So
Mm-hmm.
just follow that exact thing. Log big number over log base number. So let's go back here. Log big number, which is 61, what you have on as a numerator. There's your log big number. There's your log base number. Just plug that into the calculator. That's one. Same idea on two. Log big number. There's your log big number. There's your log base number. Okay. Plug that into calculator three. Okay. Same idea. One, two. Okay. So for three, log big number over base number. Okay. Yep. One, two, three, four is pretty much the same thing. Yeah. And then on number four, log big number over log base number. Okay, that's 1 through 4, and then 5, 6, 7, 8. Express as a single log, if it's possible, simplify, no decimals. Odd, what does that say? Odd, then, what is this right here?
Um,
Oh
I
no,
don't even know.
add. Add, then,
I don't think I completed my
oh,
sentence.
add, then I multiply, I think, maybe. All right,
Uh-huh.
let's see. Okay,
Oh
so,
yeah. Add, then multiply, subtraction, then divide.
okay. So log 4, just multiply that one and that one. Log 4, 3 times 15 is 45. That one, and then 6, same idea, except it's not multiply, it's dividing because we have a minus sign there. So log 7, 13 over 4. Yeah, what you got right there. Yep. That's 5 and 6. 5 and 6, 7 and 8. 7 and 8. Let's see what you got. Okay, for 7, you're multiplying those two, then you're dividing by that one. So log 10 times 13 is 130. Then you're dividing by 4. 130 over 4. There you go. 65 over 2. Yeah, all you did was simplify the fraction. Just reduce the fraction to lowest terms. Log 565 over 2. Okay. This one. Okay, so it's got the brackets right there. So you're gonna multiply these two. That's log 6. 9 times 3 is 27. And then, okay, let me write it down here. Log 627. Then you're gonna divide by, or let me see here. What are you gonna do? Divide by log. No, let me write it like this. What's 8? How should we write 8?
8.
Yeah, how are we gonna do this one?
Um, log 6 9.
Yeah,
Oh my gosh, my pen. Log 6 9 plus log 6 3
yep.
minus log 6 2.
Actually, no. No, no, no. This is a -1 right here. So multiply the -1 into the brackets. Well, actually, no, my bad, my bad, my bad. Do the brackets first. That's an addition sign. So this is, we're just going to rewrite this one. Log 6 2 minus log 627, right? 9 times 3 is 27.
So
Okay, so
if you just divide 27 and 2.
yeah, exactly. Log 6, is it 27 over 2 or is it 2 over 27? It's going to be 2 over 27, like that. Let me check your other notes. Make sure that's right. The first one, this first one would be the numerator. The second one would be the denominator. Let's see. Let's see your notes. Okay, so this one right here. Yep, right here. Where's my pencil? My first one is my numerator. My second one is my denominator. So 2's on top, 27's on the bottom. There's my first one. Let me go back. Where are we? Yeah, my first one is 2, my second one is 27. So the 2's the numerator, 27 is the denominator. And that's your final. Okay. Good on those two?
I think I'm good for this one.
All right. Did we do all of them? We did all of them?
Mm-hmm.
Okay, yeah, we did all of them. Look, just brush up on your properties of logs. That's all.
Exponent. Mm-hmm.
Yeah, and your exponent laws. Exactly. Yep. Yep. So yeah, you said you had to test tomorrow, right?
Yes, quiz, actually.
And do they give you the whole period for the quiz?
For the quiz, I think it's just half, so 30 minutes.
30 minutes. And how many questions is that? Like three questions, 4 questions?
For quiz, I'm gonna say like 6.
6 questions.
Usually 6 to 8 questions.
Okay. And what's your overall grade in the class? Are you doing okay?
Uh, right now, it's the new quarter. I have a 61.
What is that? A C?
No, D minus.
That's a D. Okay, so you've got your class ends in June, right? So you've got April, May.
I end May 12th.
Oh, wow. Okay, so you've
I'm a
got
senior, so I end earlier.
okay. So you've got you got 6 weeks left. All of April or 7 weeks left. The rest of March, 4 weeks April, 2 weeks in May. Okay, 7 weeks left, right?
Hmm.
And when is your final? The week of
The week after May 12th, so the 15th through.
oh, okay. Okay.
But I only have because math is the only bad grade. I only have math final to take.
Oh, you're exempt of from the other exams?
Yes, if you get higher than a 90, then you can exempt.
Got you, got you. All right, cool, cool. Look, we still got time to get your grade up.
Hmm.
If you do good on the quiz, and how much is the quiz tomorrow worth? You know?
Quizzes are, let me see.
Did she give you a syllabus at the beginning?
Yes, I'm checking my modules. I think quizzes are 30%, tests are 50.
Okay. And how many? Okay, so if quizzes are 30% of your grade, how many quizzes was there?
In the last quarter,
No, like the whole
um,
class.
whole class overall.
Yeah. So then what
Um,
I'm trying to get is how much each quiz is worth.
I'm checking.
Because then you know if you do good tomorrow on that quiz, that'll bring you up a little bit.
I had 4 quizzes in 1 quarter. So 4 quizzes in 9 weeks.
And you have 4 quizzes every quarter, right?
Yes, usually.
So that's 16 quizzes total, right?
Hmm.
So 16 quizzes total are worth 30%. So that means
Hmm.
that each quiz is worth 16 quizzes worth 30%. Each quiz is one like almost about 2% of your total grade.
Hmm.
And then when's your next test? The
My
following?
next test is um it's not published yet. I don't see. Um, but it could be changed because I don't know when my teacher's coming back.
Okay, okay. All right. Well, look, you got time either way. We got about 7 weeks before your exam, right? So we
Oh, it says April 5th.
April. Okay, April 5th is your next test. Okay, so that's next week.
Hmm.
End of next week, I think, right?
Hmm.
April 5th is, let me see here. April 5th
Next Wednesday.
is, yeah, next Wednesday. Okay. Today's what? When? Today's Wednesday. Okay.
Mhm.
And you'll get a review for that, right?
Yes.
All right. And then maybe Monday or Tuesday we can meet if you want to go over the review questions.
Tuesday preferably.
Tuesday. Okay, just email me Sunday or Monday and just remind me, right?
Yeah.
All right. All right, cool. Look, you got time. You'll be fine. Just keep putting the work in a little bit every day. We'll meet once a week. And
Hmm.
by 7 weeks from now, you should be good for your exams.
Yes.
All right, just
Thank you.
keep putting the work in. Keep, go on YouTube, go on Google, search similar questions, try those every day, half an hour, every day, 45 minutes, you'll be fine.
Yes.
Just like anything in life. If you want to be good at it, just practice every day.
Yes, that's what I need to do. Consistency for me. I get bored getting everything wrong.
Look, you got your A student every class but math, right? I was the
Hmm.
opposite. I'm flunking every class but math in gym. So look, just put in the work in every day, and you'll be great. You're already great. Just bring out the greatness even more, right?
Thank you. Yes.
You're already great. You just gotta make it just manifest it in reality.
Hmm.
That's it. That's it.
Thank you.
All right, Jordan, just hit me up next week, right?
Hmm.
All right, peace.
Bye.